Alright, guys, welcome to today's class. Sorry for the delay. I just couldn't log in somehow. Anyway, let's get started. So basically, let's start with problem one. The sum of five consecutive integers is 5. What is the smallest of these integers? Alright, so how are we supposed to approach this question? So how I would approach it is just using basically what we used before as arithmetic series. As we know, it's just increasing sequences. For example, I'm going up, up, up. Basically, say I have a sequence 1, 4, 7, 10. That's a increasing sequence. It has a common difference, or the between these are the same. Like 7 minus 4, 3. The differences are the same basically. Alright? Now in consecutive, it's just one after the another. So basically, it's just like 1, 2, 3, 4. These are consecutive integers. So for this one, it says the sum of consecutive integers is 5. What is the smallest of these integers? This clearly says that at least one of them is not greater than, all of them are not greater than 5. So we know that. Also, some of them are negative because if there's 5 total integers that sum up to 5, it's like 151 saying it. Why? Because we know there's gonna be a middle. What I mean by middle is just the average of all the integers. It's gonna be 1. And since there are 5, there's gonna be 2 on each side of it. So we can just complete it. And we just get 1, 2, 3, and 0, -1. So the smallest is gonna be -1, or A. Alright, let's go to problem 2. The number 25 can be written as the sum of 2 or 5 consecutive whole numbers. What is the positive difference between the products of the numbers of the set? Okay, so we have 2 consecutive numbers. This one was pretty obvious. We can know it's 12 and 13 just by guessing check only. Now 5. That might be difficult, but notice what we talked about. We talked about learning about a middle. What is that middle? Well, we just take the average. We first take the sum, the total sum, divided, just write AVG as the abbreviation. Sum divided by amount of numbers. This is key. So we know that the average is then 5 for the 5 consecutive whole numbers. Now we can just basically finish it. Just write the consecutive integers next to. There's 3, 4, 5, 6, 7. Now we want the product. Now what's the product of 3, 4, 5, 6, 7? Rules that 5 times 4 is 20. This makes life actually much easier to do. Now what we have to just do is then 3, 4, 5 multiplied it is just 60. 60 times 6 is 360. 360 times 7, that is 2520. 2520. Now what's 12 times 13? But then by now you can just eyeball it. It doesn't really matter what you do. It's just eyeball. Like, these are not possible because 12 times 13 is just a 3-digit number. And this gives you basically D as your answer. But to make sure, we just multiply 12 and 13 now, which gives you 2,520 minus 156, which just gives 246, I mean, 2364. 25 on 1 is 24. We still have to take out a 1 because this we need to regroup. And so there's this. And we just get 2364, or D. Alright? Let's move on to problem 4. Unless you guys have a try on this question, you guys should have done it. And tell me your answers to chat. Let's get started. I hope you have a chance. I hope you had a chance to try this out, or you guys must have done it beforehand. Anyways, 1,000 students are arranged in several rows more than 16. How many students are in the first row? And we also know the new number of students in each row are positive integers that are consecutive. All right. So one way to think about this is that, okay, you guys think it's 80. Okay. Let's see. Imagine if there's like we can make a middle. Well, the middle doesn't need to be an integer necessarily. It depends on the amount of students, amount of rows actually, in this case. So what we can do is that what we can do is just notice that there's several rows more than 16. So we know maybe let's first try out 20. If there's 20 rows, then there's gonna be dividing, it gives the middle as 50. Middle's as 50. So if it's 50 in the middle, this doesn't seem to be integer. Alright. Yeah, it does not look like it's gonna be an integer in this case. So we skip that because we cannot have like half human bodies laying around or there's just gonna be blood everywhere. But that's kind of off topic. But anyways, let's just move on to where it's odd. So that's 25. And 25 in this case, they're gonna be an average of 40. And then 12, there's gonna be 12 on each side. So like 39, 41, just show you on like the the process basically. We're gonna just put the integers on each side. This case, if it was there's just 5 integers, there's gonna be 2 integers on each side. This would be 38, 40, 42. And then if you're not sure where it's gonna be, you can just test out small values and you can see where the first and last integers are. This case, since there's 12 on each side, 40 minus 12 becomes 28 on one side, 28 on one side. And on the other side is gonna be 52. But since we want the first row, we get C is 28. Alright, now let's get started. Problem 5. The number 585 can be written as a sum of two consecutive integers, 292, 293. What is the greatest number of consecutive positive integers whose sum is 585? I'll let you guys have a try on this question and tell me answers to your chat. Um, tiny hint. I guess a tiny hint is maybe try looking at the factors of 585. See what you can find there. And then maybe make it as the number of consecutive positive integers. Alright, I'll let you guys have a try on this question and tell me your answer through private message. Guys, so let's get started with this question. So basically, we want the greatest number of consecutive positive integers that sum up to 585. So we're not going negative or below zero. We're just gonna go take the case where it's above zero. All right. So what can we do? Well, first things first. I would like first try to see the factors of 585, like I said before. So it's actually not 293, only 293, but 293 and 292. They're right next to each other. So 292 and 293 are like one apart. That's what makes them integers, and they're also consecutive. If you search up the definition of consecutive, I'm sure it tells you like it's like right next to each other, or one in between each other. Like they're basically close neighbors or friends, basically. You could just metaphorically say, or yeah, basically. But anyways, what we want to first do is just notice that if it was me, I would try to find factors of 185. What? If that doesn't work out, then I might have to look where it just basically averages out. So to get to 585, let's just look. So if it's 13 integers, 585 doesn't necessarily divide into it. I'm pretty sure it's not true. We can test it out. That's like, yeah, I don't think so. But then you want to make this. So one way to specify is 2m plus k minus 1 times k is equal to n. This is the formula we can use. Now we want the 2n as the product of two integers that are close as possible in order to obtain the greatest number. So that's basically what we chose. It's basically 2,585 or 1.170 is equal to 2 times 3 squared times 5 times 13. Where n is 585. K is basically, I don't know, K. Plus you're just gonna solve for it basically. So we don't know what K is. Okay, so if they're next to each other, they're positive. No, it's basically, what's a positive integer? Let's go back to the definition. Like the definition of a positive integer, say this is zero. We know what's one, but below zero is negative one. We're going in the opposite direction. We're going left. In a number line, if we're going right, we're positive. So one, two, three. The numbers you know since like when you're first grade, you learn about these numbers, yeah, they're positive. And once you get to fourth or fifth grade, you learn about negative numbers, yeah, it just comes in that it's on the left side of the number line, so they're negative. All right, so let's move on. So we want these two factors to be close as possible to get the greatest possible answer. So notice that we get 30, we can get 30 times 39. And then we want the smaller one, since k is indeed the smaller one, we get to choose 30, so the answer is 30. All right, are there any questions? All right, so let's move on to problem 7. I'll let you guys have a try on this question and tell me the answer to the chat. Let's get started with this question. So the answer is B. Sorry if I accidentally put yours wrong. Anyways, the number 210 can be written as a sum of consecutive positive integers in different ways. When written as a sum of the greatest possible number of the consecutive positive integers, what is the largest of these integers? Alright, so it's basically, you can easily see it's just the sum of 20 to 221 all over 2. So it's obvious that it's just going to be B20. If you just and check, because that's like the only thing that has just have to do. Just guess and check. It's just pretty simple from there. The largest actually possible value of number integers is the n, where n times n plus 1 over 2 is equal to 210. It's a sum from 1 to n. And since in this case 20 works as an integer, and if that's positive, we know it's just basically b is 20. Right? Let's move on to this question, example 12. Let's guys have a try on this question and tell me answers to chat. Okay, let's get started. Uh, let's see. Write number 105 as the sum of 10 consecutive integers. Alright. So the one for ones that use n times n plus 1 divided by 2, this you guys just got 14. Yeah, indeed it is right for you to just say and 14 is the answer. But there's only 10 integers. We only want 10 integers. So in this case, we just say, alright, so the middle number we get is 10.5. So it's gonna be 5 on both sides. We just first do 105 divided by 10, 10.5. Now there's 10 is gonna be the biggest number on the left side, and 11 is gonna be the smallest number on the right side. So you just basically think there's a barrier between this. And just write 5 integers from there. 12, 13, 14, 15. 10, 9, 8, 7, 6. Okay? So then we get 15 as our answer from there. For those of you that just use, oh wait, for those of you that just use 14 times 15 over 2, why that doesn't work is because there's going to be 14 integers, but we only have 10 in this case, right? Make sure you use it when you have like the greatest number. Not in the case of this time, like, make sure it matches up, basically. Alright? Let's move on to example 13. Basically, what we just did is just basically 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just write 5 in on both sides by first finding the middle, right? And then from there, just find the answer. Those of you that just use the n times n plus 1 divided by 2, make sure to check your work and look at the problem to make sure you're not just going on a wrong path, right? Let's move on to this question. The positive integer n times n plus 4 times n plus 5 times n plus 6 plus times n plus 7 is not divisible by the following numbers. Notice this is the product of any 4 consecutive integers. It's basically, this is divisible by the product of 4 consecutive integers. Let's just take the base case, 1, 2, 3, and 4. That gives the answer of 24. But that's not right, because that's the 24 always divides m plus 4 times m plus 5. So let this expression be 1. Okay? Or a different color. Let this be 1. This entire. Well, this is all we have n. Okay. So 24 divides n. Okay, this is really good. Why? Because as you guys later go on in your mathematical careers, you guys might learn about remainders and modulos. Modulos is just basically remainders. Notice that there's always one that's divisible by 3. Because in any 3 consecutive integers, I choose that 4, 5, 6. It's 3 consecutive integers. One of them is divisible by 3. In any 4, one of them is divisible by 4. And then in any 2, there's one divisible by 2. As you can see. So in any 4 consecutive integers, there's going to be one that's divisible by 2, 3, and 4. And all of them are just divisible by 1. So from there, we get 24 divides n. So basically, you can easily do this prove it in the future. But with our methods right now, there's not really that much possible unless just by using reasoning. Like, noticing that there's only one that has 3. But it's like never true for like the rest, right? So in this case, the factors on 24 are all over here. Like all of these are here. So you just cross them out and just get C as our answer. Alright? So maybe when you come through these questions, you think about what numbers can divide into it. All right, let's move on to problem A. Write the number 2000 as the sum of 25 consecutive even positive integers. What is the smallest among these integers? 25 numbers. As notice, it says even positive integers. It is really key, right? We first do the same steps as we did before tackling these problems when it's not even, right? Divide by 25. We just get 80, right? So the middle is 80. So that's going to be the median. If you look at sequences, that's the middle number. And it's going to be in the 25 consecutive even positive integers. Now, instead of counting back by 1, we just count back by 2. So we subtract 2. Like subtract 2 to get to 78. Subtract 2. Every time we go here to here, here to here, we get subtract 2. Add 2 in this case. Add 2 to get to 82, and so on. So now the smallest number is going to be, since there's going to be 12 numbers on each side of 80, just do the math, we're just going to have to subtract 24 because they are decreasing on increments or differences of 2. And going on the left side because we want the smallest number also. Right? From there, we just get minus 24 to get 56 as our answer. Yeah. On down to 56. The smallest is going to be D, or 56. Alright? Let's move on to problem 9 now. Let's express 84 as the sum of k different positive integers. What is the greatest possible value of k? Alright. Let's think about this. Is it all possible we just use n times n plus 1 divided by 2? Is it possible? Let's see. If you were to calculate this, 13 might work, but actually it does not work. And then 12, you can test all you can, but it doesn't work. Right? So now let's just look for the factors of 84. What do we get? Well, there's 21. If we say 21 and the middle number is going to be 4, it is going to be negative. So we don't want that. What else? We got, the factors are 1, 2, 4, 7, 8. Oh yeah, I forgot about 3. My bad. 1, 2, 3, 4, 6, 7, 8. Geez. 21. No, first. Alright. Let me just finish this problem. Alright. So let's just, okay, so basically what we have to do is just let's set the factors. And then notice that we can let k equal 7. We just find out that k equals 7 works. From there, we get 7, 8, 9, 10, 11, 12, 13, and 14. Right? That's all we have to do. And the greatest possible value of k is just 8. Oops. My bad. It's 8. Sorry. So the answer for this question is just going to be 8. Because we can just list out the factors, find out the number of integers, and then from there we just calculate the middle, and just finish up all the other numbers. We can just complete them, the sequence, right? So that's it for today's class. I hope you guys have a wonderful week, and I hope you had a good night. Have a great day.